Parabola, okay? It's a U-shaped graph. We started first with the vertex, which in this case was my lowest point at 1, -4. Then we found the axis of symmetry. That's the line that cuts through that parabola, okay? And notice the x-coordinate of my vertex and the x equals 1, those are the same because that vertex is always on that line, the axis of symmetry. So those amounts are going to be the same. All right, so now let's take a look at our roots. Our x-intercepts, our solutions are zeros. They're all the different names for the same thing. And we can find those on the x-axis. So take your pen, your pencil, whatever you have, your finger. You're going along, and here, that is an x-intercept. Okay, keep going to the other side, da 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 da. That is an x-intercept. All right. So if it's in the middle, Kenyelle, you're probably going to have 2 of them. Kenyelle, put that away and let's focus up here, okay? So what are those 2 points? We can just say the value itself because we know it's on the x-axis. We can say it is -1 and 3. -1 and 3. It's on the x-axis. You could also write them as an ordered pair. -1, 0 and 3, 0. That's up to you. Questions on that? Okay, so now can you find the y-intercept? What would my y-intercept be? Where does the graph cross the y-axis? So take your pencil, put it on that y-axis, follow it all the way down, and where does the graph intersect with that parabola? Anybody? -3, yeah. Here's my y-axis. I'm going da 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 da. Right there is your y-intercept. So that is -3, or you could write it as 0, -3. Last thing I want to talk about here is end behavior. So this one we're going to have to add on end behavior. Like what's happening at the ends of my parabola? Hey, is your finger broken? Open this up. Let's write this down. You remember it a little better. So as x is approaching -infinity, comma, f of x, the function, or y, is approaching some value. And likewise, as x is approaching positive infinity, f of x is approaching some value. Okay? So here's what they're talking about. As x approaches -infinity, so as my x values get smaller and smaller and smaller going in this direction, what is happening to my graph? It is going up. So it is going to positive infinity. And as my x values get more and more positive to the right, what's happening to the graph? Again, it's going up. So you wouldn't even have to look at this part of it that much. You just look at it and you're like, oh, it's going upward. That means it's going to positive infinity. And if it's opening downward, that means it's going to negative infinity. Okay? Questions about that? Any questions? All right, let's go to the next page. You guys are very quiet. Don't like it. Parent function. Yes, we have a parent function. A parent function is like the main parabola. It's like the parent of all other parabolas, okay? So the parent function is y is equal to x squared. That is the equation. This is a quadratic equation because it has that 2 there, all right? And my y-axis here for the parent function is going to be my axis, so I spelled that wrong, axis, my axis of symmetry. Now, I just know that because I'm a math teacher, but we want to look at what is going to happen just to the left of that y-axis and just to the right. So that's why we have selected these x values, okay? So I'm looking at -2, -1, 0, 1, and 2. I want to see what's going to happen around this axis of symmetry, all right? So I have this equation, y equals x squared. I am going to substitute these x values in for that x squared, okay? So when I have -2 and I say -2 squared, what is the answer to -2 squared? -2 squared. What does -2 squared mean? Right. It means -2 times -2, right? And a negative times negative is a +4. So this I'm going to write as an ordered pair, -2, +4. So I'm going 2 to the left and up 4. 1, 2, 3, 4. I'm going to plot that point. Okay? So then we put -1 in. What's -1 squared? Class? -1 times -1 is, no, 1, +1. So that is -1, 1. You want to plot that point right there. 1 to the left, 1 up. How about 0? 0 squared is 0. So that is the origin point. 0, 0, right there. Now we're at 1. We're at positive values. 1 squared is 1. And so we have 1, 1. And then we have 2 squared. I'll get it. 2 squared, which is back to 4. Good morning. Good morning. Let's see. I think you were here yesterday, weren't you? Yeah. Okay. So 2 squared is 4, so that is 2, 4. So as I graph both of these, look what shape we have. So then I need to connect that with a gentle curve. Okay, make sure it's more U-shaped and not a V. I mean, that's got a little bit of a point there, but that's okay. So this is the parent function. This is what y equals x squared is always going to look like. All right? Now, what is my axis of symmetry? Well, first of all, here is, well, let me back up. Let's do the vertex first. What is my vertex? What is my vertex? What is it? I need a little bit more than just 0. 0, 0. Yes, right here. This is your vertex, and that is the point 0, 0. And my axis of symmetry, I know that is this line. Shoot, I wanted that to be green, but that's all right. Oh, I can put end marks on it, my arrows on it. I know the axis of symmetry is always going to be x equals, so always make sure you put x equals, and what is the equation of that line? X is equal to what? What is the x coordinate of the vertex on that line? So that means it is x is equal to 0. So the y-axis, the equation for that is x is equal to 0. Questions about that? No? Yes? Okay. All right. So let's go to example 1. This is part of what we were hoping to get through yesterday. I'm going to do example 1 with you, and then you're going to do the check at the bottom on your own. So here we go. Axis. Nope, let's not do axis. I always like going to the vertex first, even though it's not the first thing they ask for. Okay? So, Ashley, what is my vertex? Girls? What? There's an 8 in it, yes. So I need an x coordinate and a y coordinate. -2, 8. Excellent. So right here, that is my vertex. Now, is that a maximum or is that a minimum, Miss Ashley? Maximum. Look at that. What confidence she has. Excellent. All right. Sakia, you got this. Now, the axis of symmetry is a line that goes through that point right here. Okay? What is my axis of symmetry? So, yes, there's a little bit more to it because it's an equation. We have to say, no. We have to say x equals -2. Very good, though. You got the -2. I'm very happy about that. So anytime you have a vertical line, that equation is going to be x equals some number. All right? All right, so let's go to y-intercept. Find your y-axis. Who can give me my y-intercept? Look at it closely. I think it is 5. It's kind of hard to tell, but I'm thinking right here is where that's going to cross. So I can just say 5 because it's that point, or you can say 0, 5, right? We're going to add one in. Guess what we're going to add in, guys? We're going to add in the x-intercept. X-intercept. Or maybe there's more than one. Gabby, can you give me one of the x-intercepts? Find your x-axis. And where does the x-axis cross that U-shaped graph? It is in the middle. It's in the middle of 0 and 2. So what is this going to be? 1. Yeah, we got 1. But if you go to the other side, we also have -5 because it's U-shaped or an upside down. So 1 and -5. Or you could write it as 1, 0 and -5, 0. All right, last one. As x approaches -infinity, so as the x's get smaller and smaller, what's happening to my graph? It is going to -infinity, right? So this is -infinity, and as x gets bigger and bigger, my graph goes to -infinity because they are going down. So for these, whatever the first one is, the second one is also going to always be the same. All right, so I'm going to give you 3 minutes tops. See if you can do this on the bottom. 3 minutes. Do the check. What's your vertex? What's your axis of symmetry? What's your y-intercept? What's the end behavior? Okay. I got some stuff. Pass back. Okay. All right, how we doing? Did you make some progress? So many things. All right. Oh. Are you doing that in the notes? You got the notes? Is this the notes? What are you working on that? Show me that, okay? Oh, that's right. Gabby. All right, how do we do? Well, I see some blanks. I see some filled in. Did you fill some in? You don't know? You didn't do it. Guys, you gotta try, okay? All right, so what's my vertex here? Phones away, phones away. What's my vertex, Eslaini? You got this. Come on. Excellent. 216. How many had 216? Woohoo! Rock stars. All right. Axis of symmetry. Axis of symmetry right here. I just covered up. Vertex. What is that axis of symmetry? Not, well, okay, the x is there, yes, so make sure when we say it, though, x is equal to 2. Did you say that? Who said that? Oh, yes, you're right. She's like, why is she looking at me? X is equal to 2. That is correct. How many had x equals 2? Yes, we almost have half the class, guys. All right, y-intercept. Y-intercept. These can be kind of tricky. You can look at it and you're like, oh, that looks like, oh, I'm not sure. What is my y-intercept here? Sandra, what do you think? 12. Yes, very good. 12. So right here, you find the y-axis and you follow that down to 12. Good. They don't have the x-intercepts, but if we did, x-intercepts would be -2 and what is that, 6? -2 and 6. I know they didn't have that, but we're going to have to find those anyway. And what about my end behavior? Both of those are going downward, so that means it is going to what? Negative infinity. Excellent. Great. Any questions about those answers? It's because they're both going down. Any questions? All right. Nope, we don't have time to stop. We got to keep going. All right, let's turn the page. Ooh. Now, notice we've got some different examples here. Now our parabola is not crossing the x-axis, okay? Identify the axis of symmetry, the vertex, y-intercept, and behavior. Let's go with vertex first, okay? Vertex, what is my vertex? Daniel, can you give me my vertex? 0, 3, yes. And yes, even though it is on the y-axis, I want you to give me both points, especially when it comes to the vertex, okay? So right here is your vertex. And is that a maximum or a minimum? What is it? Maximum? Is that the highest point? No, it's the low. So that is the minimum, okay? Minimum. All right, axis of symmetry. Elijah, what is my axis of symmetry? The straight line that goes through that point. It's going to be right here. What is the equation of that line? Do you know? Okay, 0 is part of it, yes. And I need something at the beginning, though. Huh? No, not 3. We have to have x equals 0. It has to be an equation, okay? But yes, you got the value. I'm happy with that. We just need to make sure, since it's a line, x equals 0. Y-intercept. What is my y-intercept? Brandon. Yeah, it is the same point as my vertex right here. So this is 3, or it could be 0, 3. It is the same. All right. So this is your y-intercept, and this is your vertex. Okay. And end behavior. Kenyelle, as x approaches negative infinity, f of x approaches what? Kenya, do you know what it is? Are they going up or down? Up. So is that positive infinity or negative infinity? Positive infinity. Yes, they are both going up. So that is positive infinity. It's either the answer to end behavior for these, it's always positive infinity or negative infinity. You only have 2 choices. Okay? All right. You might have wanted to do the check. We're going to skip the check for now, because I want to get to the axis of symmetry right here. Now, we had this little formula on page 1 of our notes. I want you to circle it, put an oval around it, box it up, something. This is the formula for the axis of symmetry, okay? And they give us an equation. Do you remember what form this is? Is it general standard form? Is it factored form? Or is it vertex form? Yeah, you just learned it. This is general standard form, which gives you the A, B, and C's. This is general standard form. So my A value is always what goes with the x squared. So A is 2. B goes in front of the x value. B is 6. And C is 3. Now, so I use this formula to find what my axis of symmetry is. So x equals the opposite of b. Well, if b is 6, the opposite of b is going to be negative 6. Divided by 2 times my a value of 2. So as I simplify this, I get x equals -6 divided by 4. That is your axis of symmetry. Okay, I probably could reduce that dividing by 2 over 2. So x would be -3 halves. -3 halves. All right. So that means I would have a line that would cut that parabola at -3 halves. And if you do -3 halves on your calculator, -3 divided by 2, you're going to get -1.5. So all of these are saying the same thing. Okay? All right, let's take a look at the next page because I don't remember what it says. More of the same. Find the axis of symmetry for the following. So here they give us general standard form and the form for the axis of symmetry. I like to put my ABCs down first. So give me the A. What's my A value? 3. Give me the B. Come on, cheerleaders, let's go. -12. No, I was not a cheerleader ever. Give me the C. What's the C value? 15. There we go. Then we use this formula. X equals opposite of B, all divided by 2A. B is -12. So the opposite of that is going to be +12. Divided by 2 times my A value of 3. So when I simplify, I get 12 divided by 6. So x is equal to 2. So you would have a vertical line at x equals 2. Hey, that's not so bad. We can do that, right, Daniel? Yeah. All right, let's take a look at the next one. Y equals x squared plus 8x minus 2. Ooh, stump the student. What's your A value here? Good, yes. This is 1 understood. That's in front. What is my B value? What is it? Excellent. B is 8 and C, ooh, this one might be a little tricky. -2, yes. Good. Now, using this formula, this is your axis of symmetry. X, okay, we're going to finish this problem. X is equal to opposite of B divided by 2A. X is equal to, if B is 8, the opposite would be -8. All divided by 2 times A. A is 1. So simplifying, -8 divided by 2. So x is equal to -4. So that is a vertical line going through -4. And you know what else we know about each of these? My vertex over here is going to be 2 something. My vertex over here is going to be -4 something because they lie on that axis of symmetry. Great job today, guys. Great job. So just a reminder, homework number 1, which you have, is due tomorrow. Okay? Front and back, due tomorrow. You guys can do this, okay? If you have not done that artificial intelligence module, please make sure you do that tomorrow or by tomorrow, tonight, because we'll probably be starting the AI stuff tomorrow, okay?